What makes AI in the space different is that it doesn't exist on its own. Like when you do something in the cloud, you got the data somewhere. It was collected somehow. It sends it to the cloud. That does the AI and then sends it back. Wearables are more like a boat in the middle of the ocean. You have to have every system on board. You have to be collecting your own data. You have to be processing it. So there's a lot of pre-processing before you hit the AI. Then you have to do the AI, and then you have to do something with it. You have to print out the results, or you have to act on those insights.
So, it's Eamon with ipXchange. This is actually our final piece of sponsored coverage for Ambiq and their attendance at CES 2024. You'll notice that the video is not actually at CES. Because AI is such a hot topic and an in-depth topic, we decided to do an Ask an IP Expert style video in the office afterwards. We'll talk about AI in general at the edge in the style that you might find on Ambiq's wearable type of devices, but also go into a lot of detail into the applications, the types of workloads that the Apollo 4 microcontroller can do, what you really need to think about when you're implementing AI on a device, and some really kind of mind-blowing things that they've been able to do. So enjoy this chat with Carlos Morales, and I hope it gives you a bigger insight into what AI can offer at the edge. Hey, it's Eamon from ipXchange. I'm here with Carlos Morales, Vice President of Artificial Intelligence for Ambiq. We did a few CES videos with Ambiq. This is actually part of that coverage, but we thought we'd get a more in-depth interview than what we got at the show so that we can really dive deep into this topic because it's very current, very topical. So, Carlos, yes, I guess the first question I'd like to ask is, Ambiq has gone into AI. They even have an Ambiq.ai website now. So what's the story of how this development started and where are we now?
Right. So Ambiq's value proposition, the reason Ambiq is famous in this industry is because we use 1/10 of the power that other equivalent chips use. Right. So silicon for silicon, you plug it into battery, we last 10 times longer. So when Ambiq hired me, it's coming up on 3 years now. It feels like 10. The challenge was, how do we use this power efficiency superpower to enable AI? And AI has been in this domain in what we call the endpoint for a very long time. You've been using things like Hey Computer and things like step detection, that kind of stuff. That's all driven by AI. The accuracy that you get from those kinds of features are AI driven, but they have to be simplistic because they use a lot of power. It's basically your CPU is running at 100% of the time, and so my boss says to me, it's like, here's a superpower. How do you take advantage of it to do AI? And that's been my mission for the last 3 years.
Excellent.
And it turns out you can do a lot.
Cool. Just out of interest, what Apollo were you guys on when you started? Because you're on Apollo 4 now, in terms of the microcontroller?
So Apollo 4 had just come out, engineering samples. I got one in my hands. I wired it up and figured out how to program it. And then I ran what we call MLPerf, which is the industry standard suite of benchmarks. That was the first thing I did. I think one weekend I was like, yeah, let's see if these guys are pulling my leg, because a lot of people, will say 10x less power. Actually, we were saying about 10x. And I thought I'd dropped to zero. Like when the benchmark results started coming back, I'm like, no, I did something wrong. And it was about 16x less power for some of the benchmarks. And I'm like, wow, no. So my wife got up, hugged my wife. I said, I made the right choice. And I came back and finished my work, because I think about that. When you have 16 or 10x in AI's case, what it means is you have basically free CPU. From a battery point of view, you're always thinking about, you do something, you go to sleep as fast as you can. And if you don't have to do that, I can spend time chugging through audio, chugging through health data, and get much better insights about that data than if you had to go, here's a little bit of fast-forward transforms and go to sleep.
Cool. So in terms of the benchmarks that you were testing against, what kind of things were you talking about? both in terms of the AI benchmark and on the benchmark that resulted in 16 times less power.
Right. So MLPerf tiny benchmarks are standard, and we only have in this space we have 4. We're part of the committee where we're working on number 5. And they're things like keyword spotting, image classification. There's something called visual wake word, which is it detects your face and wakes up Face ID, and then anomaly detection. Turns out anomaly.
Sorry, what was the last one?
So industrial IoT anomaly detection or predictive failure analysis is one of the benchmarks. And what makes this committee different from the other ones is, the other ones are doing training or inference in the cloud. They don't care about energy at all. So they just publish the raw speed with which you're doing that task. And for this area, it's very important that we get power too. So we actually publish both numbers, inferences per second or milliseconds per inference and microjoules. They publish joules, we publish.
Go on. No, you go on. No, you can go on.
No, I'm just saying our competitors tend to publish their numbers in millijoules, and we publish in microjoules.
Oh, okay. So yeah, you can see the 3 orders of magnitude difference. Okay. Well, in terms of, I guess, Ambiq, part of their big market is wearable technology, which is obviously battery powered. So when it comes to designing a wearable device and wanting to implement AI, what kind of things do people have to think about when they're designing it, both on the hardware side and on the software side, to make sure they actually get to squeeze out all that, I guess, battery life with the extended functionality?
All right. So yeah, there's what makes AI in the space different is that it doesn't exist on its own. Like when you do something in the cloud, you got the data somewhere. It was collected somehow. It sends it to the cloud. That does the AI and then sends it back. Wearables are more like a boat in the middle of the ocean. You have to have every system on board. You have to be collecting your own data. You have to be processing it. So there's a lot of pre-processing before you hit the AI. Then you have to do the AI, and then you have to do something with it, right? It's you have to print out the results, or you have to act on those insights. And so as a AI feature driven and system engineer, you have to worry about all of those steps. And you're given a battery envelope. You can't use more than this much power. And so, yes, you really focus on the AI part because that's a CPU intensive part. But you also have to collect data very, very efficiently. You have to process it, do the fast Fourier transforms or spectrum analysis if it's audio, and then you have to display it. You have to do something with it. And we find that there's really 2 kinds of AI that happens on the wrist. One is the real-time reading part. So something that's acting on audio all the time. Speech enhancement, for example, has to be kind of 2 or 3 milliseconds of latency, not more than that.
Yeah.
And then there's sleep analysis, which happens every 8 hours. So you sleep for 8 hours, it collects data very efficiently. You wake up, and it can chunk through the data for 30, 40 seconds, but that doesn't matter because, your customer's not looking at it constantly.
Yeah. Actually, out of interest, because I did have a smartwatch for a while and did the sleep analysis thing. So in terms of the sample rate, so to speak, how many samples is it taking per hour or per minute, I guess, if it's doing it very fast, in order to make a good sleep analysis?
So it really depends on the algorithm, but it'll wake up every few minutes, take a high quality sample. So it's a pretty high frequency sample, and then go back to sleep. So you want to see the heart rate, the breaths per second, that kind of stuff, and even sample audio if you want to do apnea detection.
Oh yeah,
it's one of the more sophisticated, hard to do models because it collects data from so many different sensors. They have to do something called sensor fusion.
So when you're doing a sensor fusion application, for example, like sleep monitoring, how does one train an AI algorithm in that case, because it's obviously that's much more complicated than, say, training for wake words, because that's a single data input source, I guess. But when it comes to multiple pieces of sensor data, how does one go about training that, and both in general and for implementing it using, say, the Apollo 4 SOC?
Right. Well, and I mean, I don't think anyone's ever asked me that question. It's a great question. Because in the cloud, you would brute force it. You can do an end-to-end model, say, here are the inputs. We'll do a little bit of pre-processing and feature extraction, and then let the massive model take care of it. Because models will extract and we'll figure out how to use the data themselves. And I would say the first time we implemented our reference design, we did it that way. And then we realized, well, what you really want is multiple small models. So there's one model that's doing heart rate collection, denoising. It's kind of because you have noisy kind of data coming from your wrist. And then it extracts that feature using a little bit of a simple AI, right? And then there's one that's doing respiratory rate. So instead of doing all these things in one big model, we do a bunch of small models. We call it multi-head, and then we feed the output of that to a larger model. And that's one that takes 30, 40 seconds to chew through those numbers.
Okay. And I guess is that a case of it basically collects the data over the night and then does all the number crunching, or is there any gradual are there any gradual things happening during the night in terms of that processing? For example, if I don't know how effective it would be, but if it did detect something, say, that you stop breathing or something, maybe it might vibrate to try and get you to start or something.
Yeah, if your snoring isn't waking you up, your watch isn't either. But no,
Yeah.
So we haven't done this application. But of course, some of our customers have, where they do detect sleep apnea. And at that point, you're doing it more constantly. And then you set an alarm. And this drives a good point. How often do you wake up is going to impact your battery power. What you do with that. Like, we've talked to customers that just collect the raw data. And overnight, if you're collecting ECG, heart rate, audio, it's multiple megabytes, right? So you will many megabytes. So ECG is something like 40 megabytes per minute. It's a very So you don't realize that this stuff is happening. And the traditional way of doing this is you collect that data, and when you fill your buffers, you burst it out over Bluetooth, and that uses a lot of power. So what we've demonstrated is by pre-processing, by just extracting. So ECG is just this raw kind of stuff. And the little pattern that happens in there is QRS, kind of your beat. And so you can turn that 40 megabytes into 1 or 2 kilobytes and transmit that. So even though you use more power doing the analytics, you use a lot less power overall because you don't have to transmit all that raw data. And that's a pattern we keep running into in the endpoint space.
Okay. Just to clarify, when you're talking about doing the 30 seconds of data processing, is that happening on device or is that going up?
All on device.
Okay, cool. Just double checking. So I guess that means that we've kind of covered a few bits of the pipeline in terms of these types of AI applications. So it seems to me that you're suggesting that there is a lot of sensor data, but I'm assuming the more data, the more processing is required. So if you can compress that data or simplify that data in some way, then you can further reduce the power consumption of the analytics. Is that correct?
It's the overall system power goes down. It's a trade-off that you have to make. Same thing happens with audio. Like, transmitting audio data is very expensive, right? So if all you're transmitting is a few, characters that represent that audio, you're saving power overall, even if you spent some power doing the analytics.
Okay. So outside of the wearable space, you talked about predictive maintenance, or I think some people also talk about prescriptive maintenance for industrial applications. Obviously, that's well, maybe not obviously, but I suppose in many cases you don't necessarily have to plug a device in. You don't necessarily have to have the device running on batteries for that application because it could be part of the machine itself. So if there is the possibility of doing stuff in the cloud, what are the key benefits of doing it on device when you are plugged in? I suppose would be a question.
So yeah, the distinction here is really between edge AI, where there's a bigger platform. Maybe there's a Xeon class CPU or an edge CPU, or even a smartphone class like a Cortex 8 class, and it's connected to wall power and connected to the internet, and that's basically a small computer. And so you can have it on the industrial plant. You will see a few of those endpoints, maybe 100 of them. But when you really want to instrument your physical plant, what you want is basically a sticker. You go, like, okay, this part, I care about how it vibrates. And you just stick that on there, or you glue it on there.
Okay.
And you don't have to worry about a wire going back.
Yeah. And I suppose if it's a moving part, then maybe a wire is impossible in that case.
Or if you're retrofitting a massive plant.
Yeah,
Like
yeah.
if you bought a new robot, it better have a lot of sensors on it. But if you're, doing a sheet metal place that's been there for a while, then you want to instrument that. The really good example, and I'm not sure how much I should talk about that, but this customer
Okay.
is looking at reading dials. So there's billions of analog dials out there on the planet. Your water meter.
Oh, as in...
Well, they're looking at the ones that tick over.
Okay, yeah, yeah.
And so today, the way that your water meter is read is there's a guy who comes out, reads it, right, and writes it down and goes to the next house. It's massively expensive and inaccurate. So the one alternative is cut that meter out, get a plumber to put in a new one. We all know how much that costs. Or you could slap a camera on this thing that's a battery powered camera that collects the data every couple of days. Truck drives by. When it makes the Bluetooth connection, it sucks that data. So you're saving cost. You don't have to worry about like retrofitting wires and everything to this like little box of water. You don't have to waterproof your edge device. And when the battery runs out in a couple of years, the technician comes in and swaps the battery.
Okay, cool. Yeah, that's hadn't really thought about that because yeah, I guess so there's a whole kind of thing that we have here in the UK of this drive towards smart meters, but I know from the fact that they come and install stuff. But if you can do it that way, then you could probably save a lot of man hours and a lot of money.
I think that's what people don't realize about this space, the microcontroller space, is that something like 48 billion devices are manufactured every year.
As in the MCUs.
The MCUs, they go in your Christmas lights nowadays. Your Christmas light has a computer in it. Does it really need to have one? No, probably not. But it's a massive, massive market, and it's not going to work if you have to wire each one, if you have to worry about the batteries for each one. Having this endpoint thing, is really how you ignite the market. And I would say that jives with my experience the last 3 years. 3 years ago, this was a hobbyist area. I would say AI at the edge. There was a few applications, but it wasn't practical because, you went to a VC and said, hey, I want to do AI at the edge. It's like, okay, well, what's your battery story? I have a personal story from Cisco from my old days where that was what killed the project. And 3 years now you fast forward to now, it's a real thing. Everybody wants to do it, and it's basically because it's now starting to become practical. You don't have to worry about your battery lasting a month or even days. You can work; it'll last years.
Cool. So I'm going to make a small reference to the chat that Guy had with Humi at CES. So he was talking about the co-evolution of batteries and the co-evolution of kind of AI AI at the edge. So obviously, it's from this discussion I've kind of gleaned that it's come very far very quickly, even in the 3 years that you've been working for Ambiq. What do you see as potential futures and are there any complications you see coming up in terms of the AI space and how people might want to or not want to use it?
Mhm. Yeah, I think it has come very quickly. And 3 years ago, people weren't talking about ChatGPT every day, right? And now we use it every day. What we have to realize is that there is a huge chasm between the kind of AI that you could do at the edge, ChatGPT. It's 6 orders of magnitude. The first character you type into ChatGPT triggers a cascade of compute. It's about 10 petaflops in that first second. 10 quadrillion operations happen in that first second. So that's not going to happen. That's why Microsoft is investing in fusion reactors. It's not going to happen in the endpoint. But what will happen, we already see happening, is the endpoint devices, these things that are smart, like intelligent sensors, the equivalent of our eyes or our ears. They're doing a pre-processing, very much the way that the brain does, right? There's actually a little kind of sequence of neurons that look like a neural network between your eye and your frontal cortex. So by the time your frontal cortex gets it, it's already been pre-processed, right? There's already things that you can glean from that input. And I think that's going to happen, and it's already happening in this endpoint plus cloud. We see health devices that collect heart rate, and then they use a medical large language model to ask, should I go for a run today? So your device will say, yeah, you're healthy, go for a run. The decision to go for a run or not was made in the cloud, but the data you sent up wasn't this, ream of data. It was like, here's your heart rate, here's your temperature, here's what your heart rate was yesterday. Hey, Mr. Dr. LLM, should I go for a run? So I see that happening. Other thing that's happening is technology at the far endpoint where we operate is progressing very quickly. So you can't do a large language model here. It's really a memory thing. It's not. It doesn't matter if you have zero power. These are gigabytes of RAM that you need to run the ChatGPT. But the smaller things like speech recognition, which today they need a smartphone with gigabytes. I'm seeing that move into the endpoint. So having, instead of keywords, where we interact with wearables only using certain phrases, we could have like natural language processing happening at the endpoint. Maybe the next year.
Okay. Scarily soon.
Yeah, it's soon. And again, the whole point of endpoint is you don't have to worry about that data leaving. Right now you have no control of your data. With endpoint devices, you do have control. Like your health data doesn't have to go. It can stay on your device. Your speech is fully processed on the device. It doesn't have to go to analytics somewhere.
I remember Humi talking about like kind of live translation on a smartwatch. So how are we there? I don't know if we're there yet, but how far away do you think we are of that? Around a year?
So the limitation there is memory. The smallest, it's called national NMT. I forget what the N stands for. Natural machine translation, something neural machine translation. Too many acronyms. Is memory. So we're talking about, I think the smallest model is about 300 megabytes. Because think about it, it has to have it. This model, this AI has to have an understanding of all languages, basically. It's kind of a miracle that it fits in 300 megabytes. Now, you can get 300 megabytes on a wearable device. The limitation will be, you have to power that. So the good news is NMT doesn't have to run all the time. It's a bursty thing. So it's listening all the time. When you say, hey, I need a translation, it fires that up, it turns on that RAM, you do the translation, you go back to sleep. So you still preserve batteries. Yeah, my team is working on it. Our team's job is to squeeze AI down to where you can't get any more blood out of it. And this one is one of the more challenging. Speech recognition in general, you have to recognize speech before you translate it. That's hard. and then you add the NMT behind it. That's hard as well.
So just out of interest, because Ambiq is officially kind of famous for how low power processing it can do. What is that balance between the processing and the kind of, if I said playing in the RAM, is there a lot more power going into the processing, or is the RAM part of it the bulk of the power for that kind of application?
Most of our models fit entirely on the device. So, the RAM and the flash that we have on device is super efficient, right? So if I can fit in our, 6, 7 megabytes, and I would say the bulk of the models that are at the endpoint do easily fit, then there is no penalty. If you need the 100 megabytes of off RAM, it's physics. You're wheeling external lines, and we don't make those external RAMs. Another vendor does. So you're going to spend the bulk of your power on that.
Okay, so is the RAM that will be the limiting factor if you need to use loads of it at this point?
Today, with current technology, but that's changing very rapidly as well.
Understandable. Cool. And we've got a bit more time, so I reckon I can ask another probing question. I suppose. So, say someone got an Apollo sort for development kit, and they wanted to get started developing an AI application. Let's say a sensor fusion one. What would be the access point? How would they start? Would they be using, say, the benchmark, or would they? Are there tools that Ambiq currently have immediate access to for developers?
Sure. Yeah. No, so we have a extensive set of tools. So,
okay.
Starting with something we call NeuralSpot, which is it's a neural network software development kit, and really what that does is lets you develop applications that work really well on our platform. So, setting power level high, low, channel switching, you have to know a little bit about how to do this stuff. So we automate that, right?
Okay.
Or if you want to do a demo that uses Bluetooth, or not a demo, or your application uses Bluetooth, and you want a development kit that kind of abstracts that away. NeuralSpot has a really easy to use layer, and you say, okay, publish this number, right, over Bluetooth. And then on top of that, that's the basics. That's the kernel of all our AI development. We have a library of models. So and these models are all the software is open source, free to use. It's on GitHub today. And those models range from speech, keyword spotting, speech to intent, which is kind of a fancy keyword spotting, speech enhancement, which we demoed at CES. Those are the speech models, and there's like 6 or 7 of them. And then on the health side, we have the sensor fusion library. So because it's so hard, and because the sensors vary so much, what we've done is we've broken out the core kind of components of this. We call it the health ADK. So Health Kit is the brand name, and ADK stands for AI Development Kit. And it can be as simple as, here's a sensor, what's my heart rate? And so here's a model that does that for you. And when we say model, we mean the Python side, the side that you use to train your model and extract the data and refine it, and also the stuff that goes on the Apollo 4 itself. So we give you both parts. And then maybe you care about ECG, and so here's an ECG part, and here's a O2 sensor. This is how you would kind of collect data for the O2 sensor. So the customer has everything that they need to build their own application, and then we have some example applications on top of that to show them how it's done.
Cool. I just actually remembered what my question was, or when I couldn't remember. So Ambiq, I guess your signature technology is the spot technology. You're talking about NeuroSpot. How does that differ from the original spot technology?
Oh, so this is more just having a consistent name across.
Oh, okay.
So we have crypto spot, right? Security, it's security spot or crypto spot, but that's the how we abstract all of cryptographic and then functionality. The chip is these microcontrollers are basically full-fledged computers, right? So abstracting that so that our customers can use it very easily is important. We have turbo spot. We have so every technology that we make is turbo. It has a spot in it.
Oh, okay, fair enough.
Yeah. So the irony is that using spot is almost transparent, right? You don't have to put a lot of thought into it. Like I can change clock frequencies and this is something you do. You're in low frequency while you're sampling, and then you want to compute. You turn it into high frequency, and then you go right back down. And on a typical MCU, there's a lot of limitations. You're going to lose your RAM. You're going to do all this stuff. And our chip is just a bit fast, slow, and microseconds. It does a transition. So we put a lot of thought into how you do power savings.
I guess that is the key thing that makes the batteries last for years, because you make it work when it needs to work, and you don't have it just running around the program while it's measuring nothing.
Right.
Oh, excellent. Well, I think this has been a really good discussion, and thank you so much for joining us to talk about AI. And was there anything you wanted to say as well to add?
No, I just love talking about this stuff. You can tell.
I can tell.
We are just at the beginning here. I think the kind of stuff that I see on my radar, just the other day, I talked to a company that's just listening to you and telling you, hey, you may have a mental, a neural degenerative disease,
Oh, whoa. Expand on that slightly? Oh, if you're allowed to.
Dementia detection based on your speech patterns. It doesn't understand what you're saying. So it's not really a speech analytics, it's audio analytics. So how you say things. Turns out you can... So this kind of stuff, were massive world problems, demographic problems that we're running into, detecting if you have Parkinson's, detecting if you've fallen down or having a stroke. These kinds of things will become more and more important as our world, demographics shift. And the innovation that I'm seeing in this field is massive. Now, these folks, the reason I talked to them is they were going to do it in the cloud. I was like, have you considered doing it on device? So, if you're having a health issue and you're not connected to the cloud, you can't just wait until you have a network connection back. You want it.
Yeah, of course.
Right?
Yeah.
So this is what wakes me up in the morning, right? It's like, okay, we solved the power problem. Now, how do we use it? And how do we get the rest of the world to use it? We read so much about AI taking over jobs and doing this and doing that. And that, I do think it's an interesting discussion to have. But in my world, I don't have that at all. Every day I make the world a little better. Feels good.
I think that's the perfect way to end it. So again, thank you so much for joining us, Carlos.
Sure.
Check out the full write-up about the Apollo 4 devices and this conversation on the ipXchange website. And I look forward to seeing where we are in a year's time.
So do I.
Cool. Cool. And thank you again for joining me.